Hey there, it's me, Mr. Bowers. I'm trying a new technique here called podcasts. This is a podcast, and in this podcast, we are going to learn a little bit more, get a little more familiar with Geogebra and its environment. To do that, we're going to use constructions that we've been doing the last couple of weeks in class, and using geometry software. So there's two things going on here really that I want you to make sure that you're aware of as we work along. The first thing, I want you to get familiar with Geogebra. As I construct, I'm going to point out some important features so that the more we use this program, the better you'll be at it, I hope. So at least make you aware at this point of some of the things that Geogebra does. Okay. The second thing that I want to make sure that you're trying to focus on is relating the constructions we did by hand with a compass and a straight edge to the computer software, and make sure that you understand the transition, because there is a little difference, but if you can understand how to translate one into the other, I think you're going to get a pretty good understanding of really what the geometry is doing in our constructions. Because you got to remember, constructions, we only use a compass and a straight edge. Okay. And with those two tools, we can construct any geometric shape we want, and that's really kind of fascinating, at least to me. But yeah, let's go ahead and get started. Oh, and before we get started, sorry. As we work along, again, we're going to be constructing two things here you can see on the screen. The first one we're going to construct is congruent angles. The second thing is perpendicular bisectors. So once we get each one constructed separately, we're going to do a print screen, and we're going to post that or paste that into a Word document, and then I'm going to show you how you can upload that Word document to a Dropbox folder that we're all going to use throughout the year. Okay, so now let's go ahead and get started. Okay, so the first thing we're going to do again is we're going to construct congruent angles. So in geometry, we have to use definitions literally. We have to understand what it means to be congruent angles. But I think that it's important that we understand, first of all, what an angle is. Okay, and again, as we do this, Geogebra will help us, I hope, get a deeper understanding of definitions and of what our terms really are. So an angle, we've defined an angle as two rays that share a common starting point. Okay, so that's really what an angle is. So when we construct this in Geogebra, we're actually going to use this definition literally. We're going to construct two rays, and they're going to share a common starting point. That will be our angle. And then we're going to go ahead and construct the congruent angle, which congruent angles are defined as angles that have the same measure, which are the degrees. Okay, so the degrees you hear, a 90-degree angle, and that's all that is, the relationship between the two rays, and I'll show you that with Geogebra here. Okay, so let's go ahead and pull up Geogebra. Now, when you start Geogebra, you're going to have this grid probably, or your axes, I mean, and I have my grid showing. You may or may not, but right now with geometry, it's nice to have a clean white workspace here. The grid and stuff, the axes are great for algebra, which makes this program that much more powerful that we can switch between algebra and geometric things here. So I want to get a white space here. So if you click somewhere in the screen, right click, excuse me, so if you right click, notice we have two options here, axes and grid. So I'm going to turn them both off. Right now, because I can see them, I'm going to click axes, and notice it's gone. And I'm going to click grid. I'm going to right click again and click grid and make sure that that's gone. Okay, a couple things here to talk about real quick in the environment. These up here are what are called your toolboxes. Okay, when we have lots of different toolboxes, we can customize these, and who knows if we'll get that good. But these are your toolboxes. They all do different things. Okay, your pointer tool, your move stuff, points and whatnot. So because I've been kind of messing around before this podcast, my tools are probably looking a little different from yours. But as I click these drop boxes, these down arrows, you'll see the tools that I'm going to be talking about. Okay, each toolbox has a drop arrow, which allows us to use different options in that toolbox. Okay, something else to look at before we get going, this left side here, this is called our algebra window, and it's going to show us all the things that we're constructing, all the points, segments, angles, rays, everything. It's pretty handy. And then this is just our main screen. So if you hear me refer to algebra window, it's this left side over here. and our main screen. We could look at different windows. We could view spreadsheet, what's called CAS, Computer Algebra System. We can do construction protocols. We can do all sorts of cool things. So anyways, we're just going to look at the main view in our algebra window right now. Okay, one thing I want to talk about real quick is why we use a compass in constructions and what a compass really does. Remember, a compass is all it's doing is constructing a circle. Okay, the pointy end of your compass we always put at the center of our circle. In your pencil, when you create a width, right, you change the width of your compass, it creates an invisible radius. And as you make your circle, really there's we can draw segments and construct radii as well. Okay, and I just want to show you that in Geogebra real quick. So this toolbox right here, which may not look like this, but it's our circle toolbox. If we click the down arrow, let's click the circle with center through point tool. Okay, so just click that. And now, in Geogebra, it's nice because if you highlight, now that we click that circle tool, if you highlight that tool, notice a little kind of window pops up here. It tells us what the name of the tool is, and it also tells us how to use the tool, which is very nice. So if you get confused again as we do this in the future, highlight your tool and it tells you how to use it. So notice it's called circle with center through point, and then it tells you to select center point, then point on circle. Okay, so what that means is the first thing we got to do is select a center point. Okay, so I'm just going to click somewhere, creates a point on the screen. There's our center point. Now as I move my cursor around, it's waiting for me to click somewhere to create another point. And that's that point on the circle, right, that it says up here. Then point on circle. So if I click somewhere, there's my point on the circle. Okay, now notice in our algebra window, they call the circle a conic, which is really a conic section. Don't worry about that. And it actually gives you the algebraic equation, which is pretty cool. Okay, but what's more important to us right now is the fact that we understand that, like, A here would be that pointy part of our compass, and B would be the pencil of our compass, and as you make your circle, this is what would be constructed. But really there's all these invisible radii that are made. Okay, and I just want to show and make sure that we understand the concept of why we use a compass for equal length, because that's really what, if we can understand length and we can understand angle measure, you can build any geometric figure. Okay, right now let's go ahead and construct a radius here. I want to see the segment, the radius AB here. Okay, so this third toolbox here is called your line tool or segment tool. So if you click the drop box, we have all these line options here and segments and rays. We're going to use a few of these today. So the first thing I want to do is I want to create that segment between B and A. Okay, so I'm going to grab my segment between 2 points. And all you need to do, and again, if you don't remember how to use the tool, just highlight your tool and it tells you select 2 points. So I want to find the segment AB. So I'm going to click on B or A, doesn't matter which one you do first, then click on the other point. Now it created our segment. If you look in the algebra window, notice we have here segment. It's calling that segment A. Okay, A happens to have a length of 2.31, I would imagine centimeters if you were to print this out, or that's probably what its units are. But this radius right now is what Geogebra is calling A, and that's important to know, because when we construct circles that have equal radius, we're going to use these segment labels here to help us. Okay, real quick, let's put a point on the circle here, another point here, just to show that the radii are going to have the equal length. So the second toolbox here, this is our point tool box here, and if you click the down arrow, the drop box, it says new point. Okay, so let's grab a new point tool, and what we need to do is we want to put a point on the circle. Now notice as the cursor gets on the circle gets highlighted, and that's important to understand in Geogebra, because when I put a point on the circle, I got to make sure my circle is highlighted, and then I'm going to click on it. Okay, some things to notice here. A and B. A is our center of our circle. Notice I can move A, and it's just changing the center of our circle. B is not moving, therefore that segment's getting longer as A moves away from B, or gets shorter as I move closer to B, right? That radius is changing length. Okay, I can change B, which is that radius length. Okay, our center is going to stay, but I can move B now, right? Notice the colors of A and B. They're both this kind of darker blue color. Okay, any points that are this dark blue means you can move them. Okay, they're independent points. Look at C, this point that we put on the circle. It's got this purplish shade to it. It's not the same color. And what that really means is it's our visual way of understanding that this point C that I made, it's actually kind of fixed. And because I clicked on C when the circle is highlighted, C is going to stay on the circle no matter what. Okay? So as you move C around, notice it stays on the circle. And that's why it's a different color, because it becomes a dependent object. Okay? But we still can move it with this purple color. Okay, so now let's go ahead and create a segment here, another radius, and just show that they're the same length here, and then we'll move C around. Grab your segment tool again, and create that segment AC. Notice in our algebra window, those segments have the same length, right? And that's the whole point of the compass, okay, that we use in constructions. We're creating segments that have the same length. To do that, we use the properties of a circle, okay? As I move C, it doesn't matter where C is on the line. Those segments, AB and AC, will always have the same length, right? That's the whole thing of a radius of a circle. Okay, I just want to make sure we understand that concept, because that's a huge concept to understand when it comes to constructions, okay? Whenever we use the compass tool, we're creating segments of equal length using radii, okay? A lot of the times we don't see the radius when we construct, but understand that the length between the pointy part of your compass and the pencil part of your compass, that length between them is really a radius, right? We don't see it, but that's really what's happening there. Okay, let's go ahead and construct some congruent angles now, okay? Let's go ahead and get a new clean slate here. So go File, New. We don't need to save this, okay? We got a clean slate here. Looking back at our definition of angle, two rays that share a common starting point. Okay, so let's go ahead and construct exactly what that definition says. We're going to construct two rays that share a common starting point. Okay, grab Geogebra. In our segment tool here, click on the drop box, the down arrow, and notice this tool here, ray through 2 points. Okay, so click on that. Again, what it tells us, if you highlight over the tool, it says select starting point, then point on ray. So we're going to just construct an angle here, right? So it needs to start, the ray has to start somewhere. So click on the screen, create your point, and then notice as you move the cursor, it's waiting for you to put the point down so that so it knows what direction the ray is going to take off at. So let's say that B is right here. Okay, there's our first ray. Remember, a ray is all the points that go in the same direction that are collinear from a starting point in one direction. So we start at A. Given where B is, the ray is the collection of all those points that fit that line, right, that go off in that direction forever. So the angle says it's two rays that share a common starting point. So we still have our ray tool selected. So now let's create another ray starting at A again. Here's that common starting point. Okay, notice it's waiting for me to click another point here, which I'm going to click there. There's my two rays, ray AB that I constructed and ray AC I constructed. They share the starting point A, and that's what it means to be an angle. Okay, now using Geogebra here, let's find the measure of this angle. Okay, so in your angle tool here, this is actually like our measurement toolbox. If you click the down arrow, there's lots of different options that we can measure: slope, area, distance or length of a segment, angle measure. So click your angle tool. Now as you highlight again, it gives you two options to use this tool. It says select 3 points or 2 lines. Okay, so I'm going to show you both techniques as we work through this. Right now I'm going to show you how we do the select 3 point. Okay, when you do this, it's important to understand that to measure an angle, we select the 3 points in clockwise direction. Okay, just like we label an angle, like this angle here, we could call it 3 different ways. We can call this angle A because it's the name of the vertex point. We could call this angle CAB. We could also call it angle BAC. Right? All 3 of those ways to label this angle are fine. Okay. Notice though, when we do use like BAC or CAB, the vertex is always that middle point when we label, and that's how we use Geogebra as well. So to measure this angle, I'm going to click a point that's on the ray, then the vertex, then another point on the other ray. Okay, notice the vertex is the middle point. And we have to go in a clockwise direction, right? Clockwise direction going this way. So we have to click B, then A, then C, and there's our angle. Mine happens to be 34.43, and I'm sure yours is going to be different. Okay? Alright, so there's our angle. Let's go ahead and copy this angle here. Alright, now, one thing to understand too, the important thing about an angle is the measure, which defines the angle. And the measure is the relationship between these two rays, right? Both these rays are 34.43 degrees apart from each other. Okay? In the orientation that the angle is going, notice this ray is going in this direction, this ray is going in this direction, so the orientation of this angle looks, like it does. The important thing when we copy an angle, it doesn't matter if the orientation is the same or not, because we just want the measure, the relationship between the two rays to be the same. Okay, so I'll show you what I mean by that. I'm going to try to reconstruct this angle real quick, 34.43 degrees. So I'm going to change the orientation. So what if I move C here? Now I have to move B, and I think I said 34.43 or something like that. There it is. So there's that angle, same angle measure, right? But the orientation is different. Now this ray is going in this direction, this ray C is going in this direction, but the angle is still the same, and that's important to understand. Okay, so I'm going to leave it that way, and let's go ahead and construct our congruent angle. So if you look at the instructions that I gave you, you probably have this, you should have this in front of you as well. If not, I'll kind of refer back to this. But if you get lost, refer back to your steps. Pause this video, rewind, whatever. Make sure that you can understand as you follow along. Okay, so it says here to construct an angle. Again, you have this exact same worksheet in front of you, or you should. It says start with angle BAC that we will copy, and that's the angle that we just did. It may not have the same points, but that's okay. Understand really what the construction is doing. So it says start with an angle, okay? Angle BAC, that's what we have here. Okay, so now it's saying, make a new point. What we want to do is you're going to construct a new ray, because if we're going to create a new angle, we have to have a start somewhere. So we need a starting ray. So it doesn't matter where our ray is, we need to construct one. Okay, once we construct that ray, then what it's going to tell us to do is we want to find out, create really a circle here at the center, being at the vertex of the angle we want to copy. And it says, set to any convenient width. So what we did before, remember, you just put your pencil somewhere on that bottom ray, and you created the arc, right, like they show right here. Okay, and then we want to know, where does that arc intersect this angle that we want to copy. So let's go ahead and construct that part right now. So first of all, we need to construct this new ray to start with, the ray that we're going to use to copy an angle. So in Geogebra here, grab your ray tool. Okay, just click somewhere to start a ray, and it doesn't matter the orientation of your ray. Maybe my ray is going off in this direction. Okay, again, the important factor here is to understand the relationship between the two rays is what makes the angle, not the direction that the angle is laying. Okay, that's an important concept. Okay, so now what it says is this. It says we want to find, create a radius. We want an arc that's going to intersect these two rays of the angle we want to copy. So what we can do is using our circle tool here with center through point. So grab that tool. If you don't have it, again, just click your down arrow, grab the circle center through point tool, and it just says, put the center of your circle at the vertex, and then create a convenient width. Okay, and that looks pretty convenient. Okay, so you make your arc, like in the picture here. All that arc is doing is that's really just part of the full circle we constructed, right? We have the full circle here, and that's okay. The arc, just understand, is really doing the same thing that we just did, right? Here's our arc right here. So what we need to do is we need to find out where the circle intersects these two rays at this point here and this point here. Okay, Geogebra doesn't know where that point is yet, so we need to actually construct those intersection points. So in our point toolbox, the second one here, if you click the down arrow, we have the tool intersect two objects. Okay, so go ahead and click on that tool. Again, let's highlight over the tool and see how we use it. It says select two objects or click directly on intersection. Okay, so I'm going to show you both ways you can intersect two objects. The first one says select two objects. Okay, so let's find this intersection right here. Okay, so what it means is I want to find the intersection of the circle and this ray. So I'm going to just click the circle and this ray, and notice it creates the intersection point G. Okay, the other option, again, if you highlight it, says select two objects. That's what we just did, the circle and the ray, or click directly on the intersection. So let's do that one to find this intersection here. So if you put the cursor right on the intersection, notice the circle and the ray both get highlighted, and when they're both highlighted you can click and that'll create the intersection point as well. So really it saves you one click if you do it that way. Okay, another important thing to notice here is notice our intersection points now. These are gray. Remember before we were talking about that one point I put on there was kind of purple, different than these dark blue ones, because remember the dark blue ones you can just move. That purple one you can move, but it was stuck on this circle. It was still dependent on the circle, but you can move it. The gray ones mean that they're stuck. You can't move it at all. So if you try to click an intersection point, it's not moving, which makes sense. It's the intersection of the circle and the ray, so it's defined by where those two are. So it makes sense that we can't move them. So as you see gray points, understand, and they're gray too in our algebra window, understand that you can't move them. Okay. All right. Now let's go ahead and look at what the next step is. So what we just did here was we got to step 4 here. It says draw that arc. Okay, and we found them where J and K are, those two intersection points, which are called G and H in my construction. Okay, now the next step says we want to reproduce that on our new angle here, right? So the radius that we use on this circle to create this arc, or the full circle, we want to reproduce down here. Okay, so in Geogebra, I want to use the same radius, this A here and this H, the length of this segment here. But we don't have that segment made. We have the ray AB in an intersection point, but we don't actually have the segment AH yet. Okay, so I want to construct that segment so Geogebra knows how to use it. Okay, so if you go to this third tool, our line tool, and click the down arrow, let's grab our segment between 2 points tool. Okay, and create the segment AH. You could also do AG, it doesn't matter, because remember, radii are the same length. So if we go AH, okay, notice again, here's our segment in the algebra window. It's calling that segment E. All right. So now what I want to do is I want to produce the same circle down here with my center at D, but I want to use the same radius as this one, which is, we're going to call that, Geogebra is actually calling that radius E here. Okay, so grab our circle toolbox here and click the down arrow. Notice we have a tool here, circle with center and radius. So let's use that one. Okay, so what it's saying is if we highlight over, it says select center point and enter radius. Okay, so the center point of our circle we're going to construct is D. Now a window pops up and says, what's your radius that you want to make? So I want it to be the same radius as this, which is this segment that we constructed, that segment AH, which they're calling E as well. 2 different ways to label a segment. So I'm going to put in my box here E. That's the radius I want to use. So notice I do that. It creates congruent circles here. Okay. I should probably I think we're going to need to find that intersection point. So grab your intersection tool and intersect and find that intersection point. Okay. Now let's go ahead and look at our construction steps and see what's next here. Okay, so what I did right now is this part right here. I constructed this circle, really the arc and circle, right here as well, right? Using the same radius and center at P. So now what it's saying is we want to find the length between these 2 points J, K. Okay, so again, whenever you use the compass, you're really finding equal length, segment lengths, right? So we want to know what is the length of that segment. Okay, so let's go ahead and find it in Geogebra here. So I want to find out what is the length between H and G. So to do that, let's go back to your circle toolbox, click the down arrow. Let's go circle with center through point. Now we can make the center of our circle G or H. It doesn't matter, right? Because center and point on the circle, it doesn't matter which one's which. We just want the length between these two. So I'm going to make H the center of my circle. And my second point I'm going to click is G, right? That's going to be my point on the circle. Okay, and this is what you do when you do construction by hand, right? And it looks kind of crazy right now and confusing. Just follow the steps as of right now and see if you can construct congruent angles. Okay, so that length there is really that radius of our new circle, right? So I want to find out, we need to have Geogebra know what that radius is. So we need to actually construct the radius, the segment here. So grab your segment tool. Okay, let's construct the segment GH. Okay, it's now labeled H. Geogebra labeled that new radius, that segment H. So what I want to do is look at what the next step is, which says, okay, reproduce that circle down here. So put your center at that intersection of our ray and the circle and reconstruct that circle that we just made. Okay, so grab your circle with center and radius tool. The center is going to be at I, this point right here. And now I want to construct this same circle here using this radius, which we're calling H. Geogebra is calling H. So now the radius is H. Okay, look at that. That's the same circle as there. So now this intersection must be where G is, right? So let's go ahead and find the intersection of those two circles. So intersection tool, make sure both circles are highlighted, or just click both circles. Okay, find your intersection point. Okay, and then our angle's almost done. All we have to do is create a ray now starting at D, that common starting point. Okay, and the second ray is going to go in the direction of J. So in our third toolbox here, click down arrow, grab our ray through 2 points tool, D, starting at D, going through J. And there's our supposedly copied angle. Okay, so let's make sure that it is the same angle measure. So grab your angle tool. Now remember, like I said, notice as I'm highlighting over, it says select 3 points or 2 lines. So again, if you're going to select 3 points, like you could select, if we click on that, you could select I, D, J. Make sure you go in a counterclockwise direction. And that's okay if you do that. The second option, it says select 3 points or 2 lines. So we can actually find the angle between these two rays here. If you just click on ray 1 and ray 2. Oops, I went in the wrong direction again. So if that happens, just Control Z to undo that, and now I want to go D, E to DJ. Oh, look at that. Same angle measure, right? Now, the beauty of geometric instructions is as I change certain objects here, notice everything else is going to change, right? As I change this, everything else is going to change. And as I move E, as you move things around, notice everything stays the same, right? Pretty neat. Okay, so there's our congruent angle construction. So let's go ahead and paste this into a Word document here. So the easiest way to do that as of right now is just hit the print screen button on your keyboard. Okay, so hit that. Open up a Word document. Okay, mine's already up here. You don't need to put your name on it. When we save this, you're going to save it with your name, and I'll show you how here. Well, let's go ahead and do that right now. Let's go File, Save. And here's how I want you to label this. Okay, if it's not labeled this way, then you're not going to get full credit. I want to make sure that you're following along. I'm going to save mine. Save yours to the desktop, and that's what I'm going to do with mine. Okay, so you're going to save it on the desktop. The file name, I'm going to call mine, just use your first and last name, Mr. Bowers, and then I'm just going to say, and that's okay, just use your first and last name actually. Okay, save it. Okay, so mine's Mr. Bowers. Now what I'm going to do is paste, so Control V on your Word document, paste your screen print there. Okay, I'm going to just click down a couple because we're going to do the second construction. Again, we're going to upload this Word document to Dropbox here after we finish the perpendicular bisector. Okay, so there's our congruent angle construction. Pretty neat. Let's go ahead and clean this. We don't need to save it because we already captured the screen. Okay, the second construction we're going to do is constructing perpendicular bisectors. Okay, definition. Perpendicular bisector is a line segment, or ray that bisects a line segment and intersects that line segment at a 90-degree angle. So the bisect part, obviously bisector, bisect, means that it's going to take a segment, right? Here's a segment. It's going to bisect that segment. It could be a line. It could be a line segment or a ray. It doesn't matter. Watch, I'll show you a ray. It's going to bisect it, meaning both these segments now, these two parts, are equal length. That's what it means to bisect. So these right now, we use our congruent symbol, right? Those are of equal length. And the perpendicular part means that this new bisector is at a 90-degree angle to our segment. So this needs to be 90 degrees. That's what the little square symbol means, right? That means 90 degrees, or also perpendicular, right? Okay, so that's what we're going to construct in Geogebra here. So I hope it makes sense. The first thing that we probably should do is start with a segment, right? So let's go ahead in Geogebra, grab our segment tool. So we're going to need the down arrow here. Grab your segment between 2 points and just construct some segment. Okay, it doesn't matter what it looks like. Okay, now let's go ahead and look at our steps here to make sure we do this properly. So now it says start with the line segment, got it. Place the compass on one end of the line segment. Set the compass width to approximately 2/3 the line segment. The actual width does not matter. Basically, what we need to do is we need to create a circle with a radius that's longer than half of our segment. And I'll show you why once we get it constructed. So, a couple ways we could do that again. I'm actually going to put a point on our segment here. So go ahead and grab the second toolbox here, click the down arrow, click your new point tool, and I'm going to put a point on the segment. Notice again, make sure that your segment's highlighted. C is that purplish color, which means you can move it, but it's locked on the segment now, right? Okay, so now there's my point. Now I want to create a circle, center A, with this radius that it says 2/3, but just make sure that it's more than half. So I'm going to put C, make sure that that looks like it's more than half of the segment away from A. Okay, since we're going to create a circle with this radius, then I need to find out what this radius is. So to do that again, we need to actually construct the radius using our segment tool. Let's actually construct the segment AC, which Geogebra now is going to call B, so we need to be aware of that so we can construct congruent angles, or circles, I mean. Okay, so now we have a radius B, which is segment AC here. Okay, so let's construct that circle. So grab your circle with center and radius tool. The center is A, and the radius is this B segment that we just constructed. Okay, so there's our circle, right? So I'm going to shorten B a little bit, just so you can see the picture. Okay, notice C is more than half of the segment. Okay, and we constructed that circle. Okay, now it says, again, without changing the compass width, place the compass point on the other end and construct the same circle, right? So here's that circle we just made. If we were to continue it all the way around, we want to do the same thing. Make the other end point the center and make a circle with the same radius. And that's why we want to construct that segment, so it's easy for us to do that in Geogebra. So grab your circle with center and radius tool. The center is now B, and our radius that we want to use is that little b here, again, to make sure that it's the same radius. So if we do that, okay, there's our two circles. And then to finish up our construction, all we have to do is identify those two intersection points and draw the line that connects those two segments, or intersection points, excuse me. So let's find the intersection of these two circles here. So in our point toolbox, click down arrow, click your intersect two objects, and in this case, if you click both circles, notice it finds both those intersections because the circles are going to intersect twice. Okay, so it'll automatically click that. So it has its benefits if you want to click both objects or just the one intersection point. Okay, and then the last thing that we need to do is construct a line. Now again, it could be a segment, right? I could just make the segment DE, and that could be perpendicular and hopefully bisects. I could make a line ED just going all the way through, right? And that would be a line still perpendicular and hopefully bisects. Or we can do a ray, say from E through D or D through E, doesn't matter. Either way, those are perpendicular bisectors. So again, when you look at the definition, that's why I put these three different geometric terms there, because either one will still be a perpendicular bisector. Okay, so let's just say I'm going to grab my line tool. Okay, so if you click your line toolbox here, line through 2 points. Okay, so let's click that tool, and all we need to do is click our 2 points D and E. There, is our perpendicular bisector. And let's make sure that it actually is perpendicular and it bisects. So let's check the perpendicular part. That means that this new line we constructed, has to be at a 90-degree angle in relationship to our segment. Okay, so we probably should know what this vertex point is, right? So let's grab our intersection tool and find that point F. In my case, yours might be different. Okay, now we just need to measure that angle, right? So grab your angle tool, and we just need to find one of these. And it doesn't matter, you know, if this is 90, because these are a linear pair, this angle here and this one, right? They make a line. If one of them's 90, the other one's got to be 90. And since this is a line, that these are also a linear pair. So if this was 90, this would have to be 90. And also vertical angles can argue the same thing. So what I'm getting at is it doesn't matter which angle we measure to be 90. Just measure one of them. So I'm going to measure this one here and go, remember, it has to be clockwise if you're going to do the 3 points. So B, F, D. Look at that, 90 degrees. It is perpendicular. Now as I move A and B, remember the blue points I can move. As I change things, the radius of our circle, everything, oh, notice, look, it's gone, right? This is why you had to make your radius more than half so that your circles will actually intersect. So that C looks like it must be half. It's kind of interesting to think about. But once C goes over half, notice we have intersecting circles. So that's why we had to make C more than half of the segment. Okay, so we got the perpendicular part. Let's just check bisect here. So I want to find the length of this segment A, and this intersection point looks like P. And then also B and P. So I want to make sure that these segments are of equal length. That's what it means to be bisected, right? So in this angle toolbox, this is really our measurement toolbox. Click the down arrow. Notice we have this distance or length tool. So click that, and all we want to do is we want to find the distance between A and P, which happens to be, notice now we have here in our algebra window, we have the distance of AF. Oh, excuse me, that's not F, that's P. Or excuse me, not P, it's F. So the distance between A and F is 3.09. Who cares? We just want to make sure that these are the same. So let's check this segment by clicking on the two endpoints, and notice they actually are the same, right? And again, as we move, the distances change, but the main thing is the bisecting part, meaning they're equal length, right? So you can scroll around, change things up. Okay, there's our perpendicular and our bisecting perpendicular bisector. So let's go ahead and paste this picture into our Word document. So hit your print screen, okay, grab your Word doc, Control V to paste, and paste it. Go ahead and save it. Make sure you save. Okay. And now we're done with the Word doc, and we're done with our construction. So I'm going to show you how we're going to upload this to Dropbox so I can have it. Okay. So I'm going to close out of my Word document here, and I'm going to close. We're done with Geogebra. We don't need to save that. You don't have this as part of my talk. I just want get your Internet Explorer up, okay? And I want you to go to this website. And if you need to pause this to see it, that's fine. Hey, how you doing? Go to this website. So upload Word doc to Dropbox here. So go to www.dropbox.com. Okay, so once you're there, this is our username and our password here, and this will be the same throughout the year. So the username is the email that I use for this Dropbox, rbowers1123@gmail.com. Remember the 1123, those are the first four numbers of the Fibonacci sequence. How cool is that? Password is Bowers Math, capital 1, capital B, all one word. Okay, so let's go ahead and enter that stuff. So now when you get to Dropbox, it's going to look like this, right? You should be looking at a screen that looks like this. In the upper right corner it says sign in here. Click that, enter that username and password information, okay, and sign in. Hopefully you are looking at a screen that looks like this now, right? If you don't, you should see a little Dropbox icon like this in the upper left. Just click on that, and that'll get you to this page, right? If I just click this, it gets me to the home, which is exactly what I was looking at, but to make sure that you're on it too. Okay, click your core geometry folder, click GeoGebra tutorial folder. Okay, up here right now it's empty. As you guys start uploading your files, it won't be empty anymore. To upload, click this icon up here with the white page and the blue arrow, the upload. Okay, and we're just going to upload that file that we saved on the desktop. Okay, so choose File. Mine's on the desktop. And I called it Mr. Bowers. There it is. Oh wait, that's my Word document. Okay, open. And you know when you're done when this little icon here becomes a green check mark. Okay, there it is. So I'm done. Okay, so click done. Notice now I got my file in the folder here. Okay, and I'm done. And if you can do that and you see your document, you're done as well. Okay, so I hope you followed along. Make sure that if you get lost, you pause and you rewind and stay caught up. Okay, so hope this went well, and I hope that we understand GeoGebra a little better, and I hope that we get a little more understanding of our geometric constructions as well. Okay, so thank you for following along on my trial podcast here. If it's successful, there'll be more to follow.